Hi folks, this is Professor Mughal here. This is going to be a very short tutorial on how to get started on Tinkercad and then making DC circuit, a series circuit and a parallel circuit, followed by taking measurements using multimeter. So if you go to tinkercad.com and then if you haven't signed up, you might want to click here, join now, sign up for it. I already have an account with it, so I'm gonna go ahead and sign in using my email. And then once I log in, the screen would look something like this. Okay, so notice here on the left you got 3D designs. We're not doing that. The cool thing about Tinkercad, you can also do 3D designing and then create a .stl file that you can 3D print. You have the circuits, you have code blocks that you can program your Arduino with, and then you have the lessons. For this part, for this tutorial, we are only doing circuits. So create a new circuit here, and then here you can go in and type in, rename the circuit if you like. So say I'm gonna do lab 1, say part 1, just an example. Okay. On the right, you will see here are all the components. So these are all the basic components: LEDs, resistors, push button switches, batteries, Arduino, transistors. It's got a lot of stuff on it. Okay, the very first thing I need to have is a breadboard, and I think a smaller breadboard would work because I only need to create a series circuit. So just click on it and then drag it. I just need one here. I also, the first thing I'm going to do is I'm going to pull all the components I need. I'm just going to use a resistor here, and then also an LED. I would need a power supply here to provide the power. I would need a multimeter to measure the voltage across the two components, LED and resistor. So type in multimeter here. Because we are doing two different measurements, voltage across LED and resistor, I would need two of those. So here it is. So I'm going to start off by putting the power onto the rails. So those of you who are like very new to the electric circuits and they don't know how to make a series circuit, remember on a breadboard, if I hover around this positive rail, these are connected in series. So if I connect this circuit with a positive terminal of the power supply here, okay, this basically means, and if I click here the power supply, if I say 5 volt, let's keep it 5 volt. So that would mean I'm actually providing 5 volts to all of these individual cells right here. Okay, so this rail is getting 5 volt. They're connected in series. Whereas over here in this part of the breadboard, they are connected perpendicularly, okay, vertically. So all these are connected. And also, if you look at this bank right here and also this bank right here, they are not connected with each other. Okay, so you need to keep that in mind. And similarly, you have this positive rail here connected in series. I'm also going to use the negative terminal of the power supply and then connect it to this right here. The way the wiring works is actually you just need to click on the terminal and then just drag it. You see a note here because I clicked it over here, so you get a round of shape. Otherwise, if you just connect it directly like this, so say if I was gonna do it like this, it will be just a straight line. Okay, so it might not look that good. So what you could do is just click here and then drop over here and then click again and then connect it to here. So it just makes a neat circuit. So also we would need a resistor here. With shift right you can change the orientation of the resistor. So this power supply is connected to this circuit right here. Okay. Also, one thing, notice if you like, you can change the color. So this is the positive terminal, so I'm gonna make it red. This is the negative terminal, so I'm gonna make it black here. Okay, and then this is the LED we have. Notice here, this is the anode, this is the cathode. So I'm just gonna put it over here, connect the positive terminal of the LED with the resistor, and then the negative terminal of the battery connected to the negative rail, okay, which is connected to the negative terminal of the battery. Again, because this is connected to the ground, so I can make it black, and then also this is red because it's connected to the positive terminal of the battery, and then green is basically connecting. The reason we are using a resistor here, because I want to create a series circuit. So we have two components here, resistor and the LED are connected in series, but you do want to have a resistor connected with LED in series, because you might blow up the LED if you don't have that. Okay, now remember, I have 5 volt going in. I want to measure the voltage across LED, and I also want to measure the voltage across the resistor. So I'm going to connect the positive terminal to the positive terminal of the LED. Okay, and again, maybe I can make it a little neater by maybe like this, and connecting it like this. Okay, and similarly over here, connecting to the negative terminal of the LED, and I'll make it black. Okay, and I'm gonna also connect the positive terminal to this right here to measure the voltage across the resistor. Okay, all right. I'll make it black here. So green is connected to the positive terminal, and the black is connected to the resistor. Don't have really terminals, but I was actually referring to the terminals of the multimeter right here. Okay, right now it's set to measure the voltage over here. I'm gonna change it to yeah, I'm gonna keep it to measure the voltage. And once I have my circuit ready, looks like everything looks good. We are going to run the simulation. So start simulation. Okay, all right, so we have 5 volt going into the series circuit. Remember, in a series circuit, current remains same, but the voltage across the component changes. The voltage drop according to most data sheets for a red LED is somewhere around 1.8 volts. So we are getting 1.89 volt, which is pretty consistent with the literature review. And the rest of the voltage is actually across this 1 kilo ohm resistor. By the way, you can actually go in here, select the resistor, and change the resistance if you like. So if you want to make 2.2k, you can also do that. 1k would also work. Now notice, as I change the resistance, the voltage rating change as well, and as it was expected. So the voltage drop across the LED is 1.84, and then rest of the voltage drop is across the resistor. Now if I add these two numbers, I'll get 5 volts, and that's what the total voltage supply was. Okay, so remember, in a series circuit, current remains same. Maybe now let's say I was going to work on a parallel circuit where I have 2 resistors connected in parallel. I'm gonna get rid of this LED right here. So you can just click on it and then press delete. Similarly, if you want to delete something here, you press on the wire and then press delete, and that's pretty much it. I'm also gonna get rid of these wires also, here and here. Okay, I'm gonna change the orientation of the resistor, so shift R. So maybe I can put it right here. I'm gonna pull, you can also do copy paste by Control C and then Control V, copy paste. So I've got 2 resistors, they both have a resistance of 2.2 kilo ohms. I'm going to connect the both resistor to the positive rail, so they get 5 volts each, and then the other terminal connected to the ground. Okay, if you want to, you can change the color of those wires. I'll just do it for the ground. Okay. Also, we would like to measure the current across each resistor. Okay. So once I have the circuit ready, which is basically two resistors, they both equal 2.2 kilo ohm connected in parallel, and we know from lecture number 1 and 2 that in a parallel circuit voltage always remains same. So if I'm going to find out the voltage across these two resistors, it should be same. So let's connect the positive terminal of this multimeter over here, and then also the negative terminal of this to the other terminal of the resistor. The power supply we're giving 5 volts, so hopefully we should get 5 volts at both ends. I'm gonna convert and move it to volts here. So as you can notice, the both resistor, the voltage across them is 5 volts. However, in a parallel circuit, current is not the same. It is different depending upon the value of the resistor. And now because the value of the resistor is same, we would think, we would hope that the current across these two resistors will be the same. So how do we measure current in a parallel circuit? Remember, you have to let the current flow through the multimeter, and for that you have to disconnect the resistor over here. So I'm gonna pick one of the resistor and do Shift R like this, and I'm gonna let it connect to this. So I'm getting 5 volt over here going past the resistor, and then the current, I'll let the current go past through my multimeter and then comes back again, take the route of the, then here from here it's basically connected to the ground. Similarly over here, I'm going to disconnect my resistor such that it is connected to the power supply over here. The voltage will go past the resistor. There will be a drop in the current, so I'm going to connect the positive terminal of the battery of the multimeter over here, and then the negative terminal to this wire which is connected to the ground. Okay, now if I run the simulation keeping all parameters same, I have 5 volts. I'm gonna move it to amperage, also over here amperage. Remember, because the value of the resistor is same, I'm getting the same current at both the resistor, which is 2.27 milliohms, okay, milliampere. Now say if I am going to increase the value of this resistor by 2, double it, so that would be 4.4 kilo ohms, and that would mean there will be more current opposition at this resistor compared to this. And now if I start the simulation, notice here there is less current going through, and here twice as much as I have over here. So and that's because the value of this resistor is twice as much as the value of this resistor right here. And if I add the two currents, 1.14 milliamp and 2.27 milliamp, I should get 3.41 milliamp, which is the total current flowing in this circuit. Okay, so I hope this was pretty simple and easy. Thank you for watching.